So welcome to this session. So first the characteristic equation. Let capital A be any square matrix of order n cross n and I be a unit matrix of same order. So here we consider any matrix A, so that matrix should be square matrix. So of order n cross n. So let us consider the square matrix means, so number of rows and columns should be same. So 2 by 2 matrix or 3 by 3 matrix or 4 by 4 matrix, that matrix we call as a square matrix. And here I be a unit matrix of same order. So then determinant of A minus lambda I is called characteristic polynomial of a matrix. So then the equation determinant of A minus lambda is equal to 0. If we equating the characteristic polynomial matrix equal to 0, then we call as characteristic equation of a matrix A. So next we move to see eigen value. The root of the characteristic equation determinant of A minus lambda is equal to 0 are called eigen value of the matrix. It is denoted by lambda. So solve the characteristic equation determinant of A minus lambda is equal to 0, solve it, we will get a roots. That roots we call as the eigen values. So the eigen values are denoted by generally lambda. That means suppose 3 by 3 matrix means we will get a 3 cubic equation is there. Cubic equations means so 3 roots are there. Therefore lambda 1, lambda 2, lambda 3 are the eigen values of the given matrix A. So it is also called as characteristic equation or Latin roots. Here we consider the problem with eigen values as a real numbers. The next one is eigenvector. The corresponding to each value of lambda, so there is a non-zero vector. So given matrix is 3 by 3 matrix means, so 3 eigenvalues are there. Therefore lambda 1, lambda 2, lambda 3. So each eigen values we have a one eigen non-zero eigen vector. So let us consider capital X is the first eigenvector. So entries are small x, y, z. So that should be non-zero eigenvector such that so A minus lambda I into x is equal to 0. You can replace the lambda value there. So we can solve it, we will get a eigenvectors. Here x is a eigenvectors or characteristic vector or Latin vector. So now we go to see the procedure to find eigenvalues. For a second order square matrix, the characteristic equation will be found of the form lambda square minus s1 into lambda plus s2 equal to 0. Here s1 is the sum of the main diagonal elements, s2 is the determinant of the matrix. For suppose if it is a 3 by 3 matrix, so order 3 square matrix, the characteristic equation is of the form, so lambda cube minus s1 into lambda square plus s2 into lambda minus s3 is equal to 0. Here s1 is nothing but sum of the main diagonal elements, s2 is the sum of the minus of the main diagonal elements and s3 is the determinant of the matrix. So if the matrix A is of second order, then there will be a 2 eigen values. If the matrix A of order 3, then there will be a 3 eigen values. So minor of I comma jth element is the determinant obtained by deleting ith rows and jth columns. So procedure to find eigenvectors. Let us consider third order square matrix. So we know that A minus lambda into x is equal to 0. So there x is equal to x, y, z. And non-zero eigenvectors, that is not all the values are 0. So non-zero eigenvectors means if all the 0 values means all the zeros are entered, then we call this 0 eigenvector. So here we at least one entry should be non-zero. For each value of lambda, so we get 3 equations. By using cross multiplication method, we will get a solution of the equations. That solution is called eigenvector corresponding to the eigenvalue. Similarly, for all possible eigenvalues, we have to get the corresponding eigenvectors. So now we see the method of cross multiplication. So let the equations be like this: a1x plus b1y plus c1z equal to 0. The second equation is a2x plus b2y plus c2z equal to 0. And third equation is a3x plus b3y plus c3z is equal to 0. So we can choose the non-identical two equations. If the two equations are similar, then all the entries of the eigenvector is 0. Therefore, we will take the two non-similar equations. So therefore, this x. So for I have to first two equations b1 c2 minus b2 c1, that is equal to y into a2 c1 plus a1 c2. Z is equal to a1 b2 minus a2 b1. So ratio of the solution of the eigenvector. So for cross multiplication method we should consider non-identical equations. So let the equation is x plus y minus z equal to 0 and x minus 2z equal to 0. So we can go to see the cross multiplications method. Replace a1 a2 a1 b1 c1 a2 b2 c2. So we will get this case. Therefore the eigenvectors are minus 2 1 minus 1 or we will get 2 minus 1 or both are similar. So next we go to find how to find the synthetic divisions. It will be helpful for finding the eigenvalues of the upcoming problems. So let us consider the equation x cube minus 6x square. So plus 11x minus 6 is equal to 0. So by trial and error method we can find one solution of the above. So we can replace x is equal to 0, 1, minus 1, 2, minus 2. So we will get this case. So consider coefficients. So we will get this. So after this we will find a remaining two roots x is equal to 2 and 3. So let us consider the equation, another equations. So here x is equal to 2. So to find the remaining two values we have to find the quadratic factor by synthetic divisions method. So therefore since here we can do x minus 2. So x square minus here this. Here x minus 2. So then x square minus 5x plus 6 will get this by using the quadratic equations. So we will get x minus 2 x minus 3 equals 0. Therefore from this we will say 2 comma 2 comma 3 is the root. Therefore roots are 2 comma 2 comma 3. Similarly for the next equations, here I can check x is equal to 2. The same method we will get a solution. The roots are 2 comma 2 comma 8. The next equation I can find the trial and error method x is equal to 1. So replace it. So then we have to find the quadratic equations. So from the quadratic equation the two roots are 4 and 1. So already minus 1 is the root. So minus 1 comma 4 comma 1 is the root. So now we will go to see the find the eigenvalues and eigenvector for the given matrix. So the first matrix is of the form non-symmetric matrix. The first matrix is non-symmetric. So with non-repeated eigenvalues. Eigenvalues are non-repeated 1. So first the eigenvalues and eigenvectors for the matrix A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. So the characteristic equation is determinant of A minus lambda is equal to 0, where A is this. So general form of the characteristic equation is lambda cube minus S1 into lambda square plus S2 into lambda minus S3 is equal to 0. Here S1 is nothing but sum of the main diagonal entries. S2 is the sum of the minus of the main diagonal entries. S3 is the determinant of the matrix A. Therefore sum of S1 is sum of the main diagonal entries. Here the main diagonal entries are 1, 2, 3. Therefore 1 plus 2 plus 3. So we will get 6. Similarly S2 is nothing but sum of the minus of the main diagonal entries. Therefore we can find the minus. So we will get S2 is equal to 11. Next we want to find the determinant of the matrix A. So determinant of the matrix A is S3. S3 is nothing but 6. Therefore replace the value S1, S2 and S3. So we will get lambda cube. Instead of S1 we can replace 6. Instead of S2 we can replace 11. Instead of S3 I can replace 6. Therefore lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. This is the characteristic equation. Now we go to find the roots of the characteristic equation is nothing but eigenvalues. So therefore we get lambda minus 1, lambda minus 2, lambda minus 3 is equal to 0. So from this one the roots are 1, 2, 3. So the eigenvalues are 1, 2 and 3. Now we go to find the eigenvector. So the eigenvector is given by a minus lambda I into x is equal to 0. So therefore x is nothing but x1, x2, x3. So here in the given A matrix I can take a minus lambda I. So therefore for lambda is equal to 1, we have replace it, we will get this. So from this we can multiply the matrix, we will get 3 system of equations. So from the 3 system of equation we can choose any 2 non-similar. So I can choose the first 2. So by using the cross ratio method, so we will get, so the eigenvector for corresponding eigenvalue lambda is equal to 1 is 1, minus 1, 0. This is the first eigenvector. By using the next 2 eigenvalues, we will go to find the next 2 eigenvectors. So the second eigenvalue is lambda is equal to 2. The similar way we can replace a minus lambda into x is equal to 0. We can replace lambda is equal to 2. So we will get this matrix. So first equation is this, second equation, third equations. So from this 3 system of equations we can, by using the cross multiple method, so we can find the second eigenvector. So the second eigenvector lambda is equal to 2 is 2, minus 1, 2. Now we go to find lambda is equal to 3. The same methodology what we did in the previous case. So from the 3 system of equations we can choose any 2 non-similar. So here the second and third are we can take as a non-similar. So therefore we can take as it is. So therefore we will get a eigenvector is this. So the same method of another problem. So find the eigenvalues. So and eigenvectors for the matrix A is equal to this. So characteristic equation A minus lambda is equal to this, where A equal to this. So therefore S1 is sum of the main diagonal entries. So we can find it, we will get S1 is equal to 2. S2 is the sum of the minus of the main diagonal. So we will get S2 is equal to minus 1. S3 is equal to determinant of the matrix A. So S3 is equal to minus 2. Replace S1, S2, S3. So we will get the characteristic equation is lambda cube minus 2 lambda square minus lambda plus 2 equal to 0. So lambda is equal to minus 1, 1, 2. So find the roots, we will get eigen values. So therefore there are eigenvalues are minus 1, 1, 2. So now we go to find the eigenvectors. The eigenvectors are given by A is equal to lambda I into x is equal to 0. So therefore replace your A matrix, will get this. So for lambda is equal to minus 1, replace lambda is equal to minus 1, we will get this matrix. So multiple this, we will get the first equation, second equation and third equations. So by using these 3 equations we can choose any 2 non-similar. By using the cross ratio method, so we will get the roots, the eigenvectors are 1, 0, 1. Therefore the eigenvector corresponding to the eigenvalue lambda is equal to minus 1 is 1, 0, 1. For lambda is equal to 1, we replace lambda is equal to 1 in A minus lambda is equal to 0, we will get this. So 3 system of equation. By using the cross multiplication method we can choose the 2 non-similar equations. Therefore the eigenvectors are 3, 2 and 1. So second eigenvector x2 is 3, 3, 2, 1 is the second eigenvector. Similarly lambda is equal to, we have the system of equation. So from the 2 system of equation we can choose any 2 non-similar. So therefore we will get lambda 3 is equal to 2. Corresponding eigenvector is 1, 3,